Chapter 1, Forces and Motion. Part 2, Forces and Shape.
We can say the force is the cause of motion. Suppose something is moving. We can say that some force must be acting on it, or some force must have acted on it, which produced this motion. If a person is walking, and hence in motion, there must be some force acting on it which is making him move.
Forces can make objects move, accelerate, decelerate, or change shape. Forces can make objects accelerate by applying a push or pull in a specific direction. According to Newton's second law of motion, the acceleration of an object is directly proportional to the force applied and inversely proportional to the mass. In simpler terms, when a force is exerted on an object, it causes the object to accelerate in the direction of the force. This means that the stronger force results in a greater acceleration, while a heavier object with a greater mass requires more force to achieve the same acceleration. The direction of acceleration aligns with the direction of the applied force. In a sense, forces are responsible for changes in an object's motion, whether it involves speeding up, slowing down, or changing direction. Forces make objects decelerate by applying a force in the opposite direction to the object's motion. When this opposing force is greater than the force maintaining the object's motion, it results in deceleration or slowing down. This process is described by Newton's second law of motion, and the direction of deceleration is opposite to the direction of the applied force. The heavier the object, the slower it decelerates for the same opposing force. In a sense, forces act against an object's motion to reduce its speed or bring it to a complete stop. Balanced and unbalanced forces. Balanced forces occur when the combined effect of multiple forces on an object results in no change in its motion. These forces cancel out each other, leading to equilibrium. An object under balanced forces remains at rest or continues to move at constant velocity. Unbalanced forces, in contrast, occur when the net force on an object is not zero. These forces do not cancel out each other and cause a change in an object's motion. The object may start moving, stop, or change direction due to unbalanced forces. Friction. Friction is a fundamental force that opposes motion between two surfaces in contact, arising from microscopic surface irregularities. It can be static or kinetic. Factors affecting friction include surface properties, normal force, and the presence of substances like lubricants. It is crucial in applications like movement of cars and industrial machinery. Friction is a fundamental aspect of physical interactions. We can clearly see that the man is pushing the car, but there are other forces at play. Let's focus on the forces acting on the car, disregarding the minor ones. Friction. The car's engine, gears, and wheel axles create friction, hindering its motion. This force opposes the man's effort to move the car. However, when the engine powers the car, the friction between the tires and the road is essential for traction. On icy roads, the lack of friction can prevent even powerful cars from moving. Gravity. The Earth's gravitational force or weight acts on the car. If the car were pushed off a cliff, gravity would cause it to fall. Reaction force. The road prevents the car from falling into the earth due to the reaction force. This force acts in an upward direction of the car, acting perpendicular to the road surface. Forces can make objects change shape. This can be temporary or permanent.
In the case of elastic material, they do not break easily and return to their original position, whereas Materials like glass are brittle and do not easily change shape under force. Instead, they tend to break when subjected to significant stress. Unlike the other materials like putty or clay change shape easily. They do not break and are not elastic. Permanent changes of shape. Permanent changes of shape occur when a force or temperature exceeds a threshold, leading to irreversible alterations. Unlike temporary changes, these alterations are lasting. For example, bending a paper clip beyond its elastic limit results in a permanent deformation. Similarly, heating a metal beyond its melting point causes a permanent change. A spring is a flexible and elastic object, typically made of metal, that can store mechanical energy when force is applied to compress, stretch, or twist it. When released, the spring returns to its original shape, releasing the stored energy. Springs are found in many everyday items, from mattresses to trampolines, absorbing and distributing force to make mechanisms work efficiently. In the year 1676, the scientist Robert Hooke made a significant discovery. He stated that the strain of the material is proportional to the applied stress within the elastic limit of that material. This essential scientific principle is now known as Hooke's law. It is also important to note that Hooke's law only applies when an elastic material isn't overstretched. Moreover, this fundamental concept isn't limited to wires. It applies to springs and similar elastic objects as well. When we pull or push them with opposing forces, the extension of the spring is directly linked to the force we apply. On this graph, the x-axis shows the applied force in newtons, and the y-axis shows how much the spring extends in meters. As the force gets stronger, the extension of the spring also increases proportionally, making a straight line on the graph. This straight line pattern is what Hooke's law is all about. But it's essential to notice the point where this